Hi, my name is Cecilia Mercado Espinosa. I'm a high school student at Tech Milenio, Group 424, with Claudia Bautista Reyes as my teacher, taking the Mass and Energy subject. I am going to talk about all the topics I have seen through the semester. I will give examples and I will define meanings in order to a better comprehension of my viewer. Okay, I would like to start this video by explaining what physics is about. Physics is the science that searches fundamental concepts of matter, energy, and space, and their relationship among them. Physics is one of the oldest sciences. Nowadays, one of the interests of physics is to provide knowledge from basic to complex, developing a clear perception of situations of certain analogies that allow solutions to new problems. Physics is divided into two different branches, classic and modern. Classic is developed between 17th and 19th century and it deals with small velocities compared with light speed, and modern is developed almost in 20th century and it deals with velocities near light speed. Measuring is a process that consists in comparing an unknown magnitude with another already known in the same unit of measure.
For example, if you want to know the length of a pencil, you use the length of a rule to compare.
The International System of Units is the most used unit system around the world.
It defines 7 fundamental quantities which have assigned 7 basic units and their symbols.
It is possible to measure many more units like volume, speed, force, and pressure. These are combinations of fundamental units.
These combinations are known as divided units. In the next chart you can see several units of the United States customary unit system, known also as USCU.
An advantage of metric system in comparison with other unit systems is the use of prefixes.
In the next chart we define some of the accepted prefixes.
People talk about different kinds of quantities such as water, money, distance, speed, weight, time, and temperature. We are going to talk about physical quantities and their classification. Some quantities are only described by its unit and number. This type of quantities are called scalar quantities.
Examples.
On the other hand, there are some physical quantities such as force and velocity that have direction and also magnitude. These kind of quantities are called vector quantities. This consists in a number, unit, and direction.
Examples.
The result of a vector sum is known as resultant vector. There are two methods to sum a vector graphically: parallelogram method and tail-to-tip method. The parallelogram method only works for two vectors.
First, you have to draw with the proper scale both vectors coming from the same origin point. Then, with the use of triangles, draw parallel auxiliary lines that are going to touch the tip of each vector. Doing this, an intersection of the auxiliary lines is formed. The result of the vector sum is the resultant vector that is formed when the origin point and the intersection are joined together. The tip of the resultant vector is at the intersection. The direction is measured from the origin point.
The tail-to-tip method works with two or more vectors.
It consists in drawing with a proper scale one of the vectors, then where the first one ends at the tip of the arrow, we start drawing the second vector and we continue in the same way until all the vectors we want to add are used. The result will be the vector that is formed when you join together the origin at the first vector with the tip of the arrow of the last vector you drew.
Every day we use without distinction words like distance and displacement. However, in physics they have a very quite different definition. Distance is the length of a path followed by an object, and displacement is a separation in a straight line between 2 points, the initial and the final one.
Speed is the travel distance per unit of time. It is a scalar quantity. Velocity is a displacement per unit of time. It is a vector quantity. Acceleration is the rate of change of velocity per unit of time. It is a vector quantity.
Every object on Earth undergoes to the same force, the force due to gravity. This force is always directly towards the Earth's core. In vacuum, all the objects fall with the same acceleration.
As we all know, Galileo Galilei was the first to suggest the concept of gravity, changing many of popular beliefs of his time.
In free fall, we assume that the initial velocity is zero. Also, the final velocity and position will going to increase negatively because the initial velocity is zero. Gravity always must be negative. In our daily life, there are more kinds of motions in many objects and things, and this shows an interesting behavior that we can predict with physics.
A projectile is a particle that moves near the Earth's surface only by its weight. Using the equations, we can analyze the behavior of the projectile along its trajectory, also known as parabolic motion. However, in physics and math, there is a unit that is used a lot and establishes the relationship among the arc and the radius of a circle. This unit is the radian. The angle of a radian is a central angle which S is equal to the radius r, and it is defined by the following equation.
First law, inertia, states that in the absence of an external force, the object that is in resting will remain this way, or if it is an object with a state of motion at constant speed, it will continue this state. Second law, motion, states that the acceleration that a body acquires is directly proportional to the applied force and inversely proportional to the mass. Third law, action-reaction, states that for every action force there is a corresponding which is equal in magnitude but with an opposite direction. There are certain forces important in physics, such as weight, tension in a rope, and friction. Weight is the interaction of a mass with the gravitational field produced by the Earth. Tension of the rope is every point of the rope due to the application of two equal forces in every end of the rope. Friction means that two objects are in contact. There is a static and a kinetic friction. Static friction is without relative motion, and kinetic is with a relative motion.
For the last three topics, I'm gonna give examples. This is the first example.
Find the tension on the ropes A and B for the next figure.
First, we must do the free body diagram. Now we do the sum of forces in both axes. We can obtain the value of A and the plug in the other equation to find B. This is the first example. A lawnmower is pushed in a 20-meter horizontal distance by a 200 Newton force, directed 30 degrees to the ground. What is the work done by this force? First, we can do a free body diagram where we show the displacement and the force. As the formula indicates, we only use the horizontal component of the force. The unit for work is Joule, so the final result of this exercise is. The other example is of kinetic energy. The only thing we've got to do is substitute the values of the formula, and we end up with this result. We establish that the last in the highest point of the roller coaster has only potential energy, which will be equal to the kinetic energy losses, where the high is zero and means there is no final potential energy. Masses are cancelled out. And finally, we solve the formula for velocity.